Hello and welcome back. So in the last session, we have separated our data set into training and testing set, as you could see. We have splitted our data into four main sets, including the train set and the X tests, plus the Y training data and the Y testing data. So after we splitted our data, the next step here is to choose and select the model that we are gonna use to train our data on. In order for us to train our model, we are going to try three main different machine learning model, including the logistic regression and the nearest neighbor classifier and the random forest classifier. Just to give you an overview about these machine learning models, so the first one, which is the logistic regression. The purpose of using logistic regression is used for binary classification problems, where the goal is to predict one of the two possible outcomes. In our case, we're trying to detect disease or no disease. So this is one model that we are gonna try. How does logistic regression works? The model works with the finding the relationship between the dependent variable, which is the target, and one or more independent variable, which in our case the feature variables. Using logistic function, the output of the model is a probability between 0 and 1, which is mapped to class label 0 or 1 using the threshold, often like 0.5. So as we mentioned, the main application that we can use logistic regression here, it's mostly and commonly used in fields such as medical diagnosis like predicting disease presence, also in marketing field like predicting a customer churn, and finance, so predicting loan defaults and fraud cases. Next on list we have the nearest neighbor classifier. Let's talk about the purpose. KNN is non-pragmatic and instance-based learning algorithm used for both classification and regression tasks. For classification, it's primarily used to classify data points based on the class labels of the nearest neighbors and the feature space. But how does it work? Let's say given a new data point, the model identify the k closest data point, which we call the neighbors, based on some distance matrix like the majority class label among the neighbors, and also whether it's assigned to a new data point. Where KNN is used, KNN model, it's mainly used in recommendation system like recommending movies or product, also image recognition and medical diagnosis sometimes, where the patterns in the data point you can detect it, with reviewing the images or symptoms, which is used to make the prediction. So the last third model that we're gonna try here is the random forest classifier. So the random forest classifier, the main purpose for this model is to ensemble learning method used for both classification also and regression. It combines multiple decision trees to improve accuracy and robustness of the model. Remember that decision trees are very important in medical field, since it can prove the interoperability. But how does random forest work? The random forest algorithm builds multiple decision trees using bootstrapped subset of the data and random subset of features. Each tree makes a prediction, and the final class label is determined by the majority of voting. Some application for the random forest is used, including like finance when doing credit scoring, also in marketing, customer segmentation. Also, it can be used in finance like fraud and banking fraud detection, and biology when you want to predict disease outcome, which is also in our case. due to its ability to handle large dataset with high dimensionality and its robustness to overfitting. To summarize, when to use each model. So we said in logistic regression, we use it when we have a primary classification problem in our case and need a simple interpretable model. The next one, which is the k nearest neighbor, it's used when your data set is smaller and you want a simple, innovative model. It's often used in scenarios where the interoperability is not a priority, but performance is a key. The last summary for the random forest, it's used when you have complex data set with many features and potential interaction. It performs well with even noisy data that can be used for both classification and regression tasks. Let's now start coding to build our main models that we are gonna use. We'll start by defining the models. Think as creating a dictionary for each of these models, and then we will create the function to fit our data and to score and to obtain the scores of each model when we fit the data. Also, we're going to set a random seed and then make a dictionary to keep the model scores, within the function itself. And we will see each of these steps one by one. To start with, let's first define the model we have. Let's call them as models. And we'll have to open, okay. The first one we have is that use logistic. As you could see, you have it here, logistic regression. The next one we have is the KNN or K-neighbor classifier. Let's start defining it by saying that it's equal to KNN. That's gonna equal to KN neighbors classifier. The third model we have is the random forest. Let's call it as random forest. That is gonna use the random forest classifier as you could see. Now we have successfully created the dictionary for each of the model that we're gonna use. Next, let's create the function to fit and score the models using our train data, the X train and the X test, including also the Y train and Y test data. So let's just comment this. Let me add some comments as well here. Here, as we said, we have to create function to fit and score models. To start with that, we are going to define f function, which is called fit, and score. Now we're going to put our models, the one we just created here, so let's set that now to models. As you could see, it's equal to the same models that we just created, logistic regression, KNN, and random forest. Next, now let's choose the data that we are gonna use, including the X-train. You remember the one we just created, including X-test, also Y-train and Y-test. Done from this part. So as you recall that the X-train, it's the training data with no labels. The X-test, it's the testing data also, but without labels. The Y-train, it's the training labels, which we call it in our case the target variable, which is 1 and 0. And the Y-test, it's equal to the test label for the target variable. Now let's set a random seed. So as usual, we'll call np dot random dot seed, and we will set that into 42. What also we should do is that we also need to create some sort of dictionary for the scores that gonna be stored. So let's call this make a dictionary to store models score. So you have to think of each of these models will have a different score. So to start with that, we'll create something called like model scores. Model underscore scores, which is equal to open practices. Okay. Now let's create something called for loop. For loop is used as a function, to keep looping within the same function. So we can get the 3 results for the 3 different models. Use for loop to loop through models. To do that, we can start by just defining start with for, call it name, and then we'll call it model in our models, if you recall the models that we just created, which is this one, dot items, to access all of these variables that you could see, including the logistic regression, the KNN, and the random forest classifier. So these we call them as items. Let's now fit the data, fit the model to the data that we have, including the X train, Y train, and X test and Y test. With that, we can just use model.fit. So we'll use our X train as we mentioned, and also Y train. It's a small letter, so train. Now close that.